All right. So as you can see, the resistor and the inductor, they are connected in parallel. Why are they connected in parallel? Because two elements, or elements that share two nodes, right? They share this top node and then this bottom node. Elements that share two nodes are in parallel, and elements that are in parallel share the same voltage drop. So we can actually combine the impedance of the 5 ohm with the impedance of J5. So that's going to be, let's see, 5 times J5 over 5 plus J5. And then we know that the voltage drop across this 5 ohm resistor is going to be the same because they're in parallel. Right, okay, so J25. Okay, cool. Cool. Okay, now let's redraw our circuit. And then I'm just gonna put a box, but really it's yeah, I'm just gonna put the box for now. I'm just gonna call this Z of the right hand side. Okay. So we know that the voltage drop across this element is going to be 8 angle 30. So what can we do? Let's find the current in this mesh, right? Trying to find the current that goes through here. I'm just gonna call this, what are you gonna call this? We'll call this, I don't know, IZ or some shit. Okay, here's IZ. Or we're doing the Ohm's law. So V naught, which is equal to 8 angle 30, is going to be I times Z, right? Where the Z is the impedance of the right hand side. Okay, so we have 8 cosine 30 plus J8 sine 30 over ZR, right? We have that all over that right impedance because we're doing an Ohm's law right here. Oh yeah, J25 over J5 plus 5, right? Yep, there we go. Okay, so once you convert this, you're going to get something like X plus JY, right? After you do some calculator stuff, you are going to get, I guess you can keep this in 8 angle 30. 8 angle 30 over, sorry. Over 3.5355. Okay. Then we just reduce this. What is this? 2.2627 angle minus 15. Okay. Now, the last step is we just do a current division. So for okay, wait, I'll do this in blue. Okay, so for I of S, or no, sorry. I guess for IZ, right, we'll say, if we had to do a current division for this I of Z, it would be equal to the source, or the source current, right? Because we have, it goes down two ways. It goes down this way, and then it goes down this way. And then we just do current division rule right here. So to find this I of z current, for current division rule, we do the opposite branch over the branch we're looking at. So it would be 10 over 10 plus minus j5. Fuck. Oh my gosh. Fuck. So much algebra. Okay. Minus j5 plus. I'm just going to write zr. You guys can do this later. Plus zr. Right, where ZR would be, right, this piece. And then we solve for that up here, right? So plug in ZR to that. And then you plug in I of Z, which is this value. And then plugging in all those values, we get I of S is equal to, right, I of Z, or that right hand, that other mesh times the reciprocal, right? Because we're basically just switching these two variables, right? I of S comes to the other side, or you're multiplying the I of Z by this bottom portion, or you're multiplying, you're multiplying I of Z by this reciprocal, right? To switch I of S and I of Z, we just have to multiply the other one by the reciprocal. So let's do that. Oh my gosh, I'm not plugging these values in. This is this, and then this is this, right? All right. If you guys found this, if you guys found this video helpful, you know what to do. Dislike, leave some hate mail, messages, unsubscribe, all that good stuff.